Hi, I'm Kayla, and in this video I'm going to be going over how to solve a system of equations. Generally, when we say solving a system of equations, we're talking about the intersection of two lines. So I have two examples. I'm going to use just ones that I've made up, so I haven't solved these yet. So we're going to get some fractions. So we see that equation 1 and equation 2. One is in the y equals mx plus b form, which tells us the slope, m, and the intercept b. So this video is assuming you already know the basic components of a line. And the second equation is in standard form. Now, I like to graph them so that I can see what I'm looking at, and also to see that the two lines aren't parallel. So whenever we're solving a system of equations, we have two answers. Mostly either the lines are parallel or they intercept. So if two lines aren't parallel, they have to intercept somewhere. So when I look at this, the first one is already in that slope format, but I'll rearrange the second one. So for the second one here, I can see that I have a negative slope and a y-intercept of -1. Compared to the first one that has a positive slope of 2 and an intercept at 3. So if I were going to graph these, then my first one would have an intercept at 3 and have a slope of 2/1. Whoops. So that's kind of going through right there. And then my second one has an intercept at -1 and then the regular 1/1 slope. So now I know that I'm looking for an intercept around this point here. And they do intercept because the slopes are not parallel. Okay, so for solving this, I'm going to use substitution. However, you could also use elimination. Either will work in any system of equations. Normally, if two lines are given in standard form, you're going to use elimination. I prefer using substitution in general, though. So now what we're saying here, the reason behind substitution is that if we look at the graph on the right, we know that at this point here, or this is what we're solving for, this is our solution. At the solution point, and that's important too, it's a point, not a value, it's a point. The x and y of both lines are the same. So if I'm looking at this line here, you know, my x is -1 and 1, or -2 and 1, and then -1 and 0 perhaps, and it's going on. But at some point along this line, the point x and y of my first line and the point x and y of my second line are the same. So what this means is that at this point, the x of the first line and the x of the second line are the same, and the y of the first line and the y of the second line are the same. So now I'll go back to my equations. So what I'm really saying is, at what point in both of these lines are my y's equal, and at what point in both of these lines are my x equal? And that's why we're using substitution. I lost my cursor. There it is. Okay, so what I need to do is I need to set them equal to each other. So for the first equation here, this is our y1, and then the second equation we have our y2, just meaning that it's the y of the second equation. So y1 is equal to y2, where y1 and y2 are the y's of my first equation and the y of my second equation. So if they're equal to each other, then I can set them equal to each other in the equation. So this y is equal to the same as this y when I'm looking for a solution. So now, because I have this y isolated, and this y was already isolated, I can set these equations equal to each other. So I'm running on a slant. Okay. So now I've said that they're equal to each other, and I only have one variable left. And that's part of the reason for substitution. So when you substitute, you should have only one variable left to solve for, because of course, in this case with a linear equation, we can't have two variables in the equation and also solve for one of them. It doesn't make any sense. Okay, so now what we need to do is rearrange for x. So I have an x over here, an x over there. Assuming you know how to rearrange, it's simply going to be 2x plus x is equal to negative 1 minus 3. I'll write that out. So 2x plus x is equal to negative 1 minus 3. If that's confusing for you, then I'll make a tutorial on BEDMAS, but that's just simple rearranging. So now I have 3x is equal to negative 4. And then to solve for x, I need to get rid of the 3 in front of it. So x is equal to negative 4 over 3. Now this is a point when a lot of people may stop their question, but you're not done it yet. So what we have right now is this x here. We haven't solved for the y value yet. And remembering that when we're asking for the solution for a system of linear equations, we have to have the full point. So a point is an x and a y, so you need to have the y value. So now we go maybe onto our third step, we'll say, and that's solve for y. And you could have solved for y first. It doesn't matter which order as long as you solve for both of them. To solve for y, we always use this x and we substitute it back into one of the original equations. Now some people ask, can I use equation 1 or 2? It doesn't matter, but as a general rule of thumb, use the one that you didn't rearrange just in case you made some sort of mistake in rearranging. So I will use the first one. And also in this case, y is isolated, so that makes it easier to solve for it. Now remembering that x is negative 4 over 3, I can plug that in here. And that makes sense because remembering that the lines intercept, I have found that x-interception. I have found when both the lines intercept, at what x value they both intercept, and that's negative 4 over 3. So by plugging in negative 4 over 3, I'm asking myself, what is the y value when both the x values of the lines are the same? Okay, and then you want to do a common denominator to figure out the final answer for this, and you'd have your point. I lost my pen. There we go. So we know that has to be over 3, so we'll times the top by 3. And then this is negative 8 plus 9 all over 3. Or sorry, plus, yep, there we go. Plus 9. And that was, of course, my y, followed from previously. Okay, so now I have my final answer, which is the solution xy, negative 4 over 3, and 1 over 3. Don't cancel out the 3's. Some people do that, but you need them in this answer because that's the right value. Okay, so here we have the final solution. So I would use one of those therefore statements and say the solution to this equation is negative 4 over 3 and 1 over 3. And then the final thing is that I look over here at my lines, which, weren't really drawn that accurately, but it should be somewhere in the ballpark. So I was expecting a negative x value, which I got, negative 4 over 3, a little more than 1, and then I've got a positive 1/3. So really the interception was about right there. Okay, so that's it. I'll do another video on elimination. Thanks for watching.